We're gonna do this. So this next section is on graphing exponential functions. So I'm going to start with you. I'm just going to kind of flip back and forth between the applied and pre-calculus work in order to do this. Okay, so an exponential function looks like this. F of x is equal to a. You have a base, and the exponent has to have the x value in it. So this is what we consider an exponential function. A cannot equal 0. Okay? B has to be greater than 0. And b cannot equal 1. The graph of an exponential function can have two different shapes as shown. All exponential functions in the form f of x, a, b to the x, where a is greater than 0, b is greater than 0, b equals 1 have the following characteristics. Okay, so here's what I want to do. First things first, I would like you to, on your graphing calculator, I want you to graph y equals 2 to the x. So let's start with that. Graph y equals 2 to the x.
The plot has to be off, right?
Yeah, take the stat plot off. Use the stat plot. And change your window back to minus 10, 10, minus 10, 10. No. That only matters if you're doing true. Okay? All right. I also want you to graph this. Y equals 5 to the x.
Just goes up faster.
Goes up faster, right. Okay. So what we want to do is we want to take these two graphs and we want to establish 4 characteristics of these two graphs. Okay? First characteristic is, where does it cross the y-axis? What's the coordinate where it crosses the y-axis?
Like 0, 1.
0 and 1. Now I want you to think this through for a second. Plug 0 into the equation for x, looking at it on the board. What is 2 to the power of 0?
It's
What's 5 to the power of 0? It's 10 to the power of 0. Right? Anything to the power of 0 is 1. So a graph in which you've got a b value that's greater than 1 is always going to cross at 0 and 1. So there's your first characteristic. Y-intercept is equal to 1. Let's look at the domain for this graph. What is the domain for this graph? How far left does it go? Okay. So x is an element of all reals, right? It's my domain because it goes to negative infinity on the left and positive infinity on the right. What is the... Go ahead.
Will it not cross the x-axis?
No, we're going to get there right now. Okay? So, second thing is, what's the range?
Y is greater than or equal to 0.
Y is greater than or equal to 0. We get that, correct? But, what's that? Not equal to 0. That's right. Y is greater than 0, okay? Which means we have an asymptote. And what is our asymptote in this case?
0.
Our asymptote is y equals 0. Okay, so that's important. So I should actually add that into my graph. All right? When they use the axes, they sometimes don't add them in, but I would always add in that asymptote. Make it known that you understand that there is an asymptote there. Because when we translate this graph, when we move this graph from this coordinate, let's say we move it up, that asymptote has to go up with you, so you want to make sure that you're drawing it. Your calculator will not draw asymptotes up. They may draw the odd vertical one, but they will not draw the horizontal one. So you want to make sure that you understand that that's there. Okay? And the fourth thing that we want in applied, which we don't really pay attention as much to in the pre-calculus, okay, is the end behavior. What's the end behavior for this graph?
2 to 1.
What is it?
2 to 1.
2 2, 1. Great. Okay. All right, so far? Okay. All right, now, let's just play with it a little bit now. Okay? So let's go back, take away the 5 to the x graph on your calculator. And now what I want you to do is I want you to graph y is equal to. All right, so before I graph it, what do you think is going to happen here? Hold on. Before you graph it, explain it to me. It's going to what?
Flip over the x-axis.
Flip over the x-axis. It's going to reflect over the x-axis. All right? I agree. So what's it going to look like?
Complete opposite.
Should be that. Okay, graph it and find out. Is that what it looks like?
Yeah.
So now what is my range? Y is less than 0. What's my domain?
X is in
What is my end behavior?
3 to 4.
3 to 4, right? Okay, so that's all that happens here.
Now the y-intercept is.
And what's my y-intercept?
-1.
-1. Very good. Okay, so far we're okay? All right, how about this now? Okay, before you graph it, I want you to think this through. Okay? What do you suppose is going to happen here? Don't graph it yet. Don't graph it yet. You think it's going to stretch horizontally? Anybody else want to throw something up there?
No, the x-axis.
Your tie's right. Anybody want to throw something else up there? Okay, I want you to think this through now. Okay? When I go back here, all right, and I do a table of values. So don't do this yet. I want you to listen. Put your pencils down and listen. Okay? When I'm doing this graph right here, okay, my table of values. When y is equal to 0, or sorry, when x is equal to 0, what is y?
1.
1. When x is equal to 1, what is y?
2.
When x is equal to 2, what is y?
4.
When x is equal to 3, what is y? 8. When x is equal to -1, what is y?
2 still.
When x is equal to -1, what is y? So what am I asking you? Y is equal to 2 to the -1. What is that?
Oh.
Oh my, how we forget? Exponents. What do you do to make a negative exponent a positive? What do you do? Reciprocate it. So when it's 2 to the -1, y is actually equal to 1 over 2. When when x is equal to -2, y is equal to 1/4. So what's happening here?
It's going.
It's getting closer and closer to my asymptote, right? The further I go out this way, the smaller the fraction becomes. 1/8, 1/16, 1/32, 1/64, right? 1/28. So it gets closer and closer and closer to that asymptote. Okay, so now you got that in mind, right? Okay, I want you to go back to this now. What do you think happens here?
Is it gonna go the opposite way? Like it starts up high in 2 and comes down to low in 1?
Graph it and see if that's what happens. Is that what we look at? Is that what it looks like? What is my y-intercept?
1.
Still 1, right? Okay. My end behavior, still 2 to 1, correct? The only thing that changes, and we would call this a decreasing graph. Okay? Because it decreases going from left to right. The other ones are considered increasing. Okay, so that's a decreasing function. So by putting a half in here, all right, so now, here's my next graph. So does everybody understand that now? As to why that happens? So when x is equal to 1, I got a half. When x is equal to 2, I got a quarter. X is equal to 3, I got an 8. 4, a 16. So what's happening over here? It's getting closer and closer to my asymptote. As it gets larger, as x gets larger, y is getting smaller. Fair enough? All right, so the next thing I want you to look at then is this. What happens there now? Okay, so now I'm going to use, for those of you that have done the pre-calc up to this point, when that negative is placed in front of the x, what is supposed to happen? No? When that negative is in front of the x, what happens to the graph? Which way?
Yeah, no, false.
What values am I now changing by placing the negative in front of the x?
Values.
My x values are all changing, are they not? So then my negative x values become positive and my positive become negative, correct? So which way does it reflect then? Over which axis?
The y-axis.
Should reflect over the y-axis. So what should my graph look like? This graph should then look like very similar to what graph? The one we just did? Is that what it looks like? Graph that in your calculator. Make sure that we have that right. Are those not the exact same graphs? Okay, so this is your 2 to the x, right? This is 2 to the x right here. Is it? Or is it 2 to the negative x? 2 to the negative x, right? Okay? Now, I want you to think about this for a second, please. What did I do here? Well, I took that 2 on the bottom, moved it to the top, and gave it a negative exponent. Those are exactly the same graph, right? But when we do this in pre-calc, all right, you talk about it in terms of what's happening to the graph because of where the negative is placed. So the first time we did this today, I placed the negative in front of the entire equation, which then made that a reflection over. My y's all changed to here. Now, because the negative is in front, my x's all change. Okay, and they flip over that y-axis. Fair enough? Okay. So this is actually 2 to the x, and this is 2 to the negative x. Okay? Your original graph was this yellow, and then we flipped it. Any questions so far? Okay, let's flip over to 180. There's not much in 7.1. It's just using your graphic calculator. Okay? So relating the characteristics of an exponential function to its equation. For an exponential function, there's a constant ratio between consecutive y values when the x values increase by the same amount. In an exponential function of the form y equals ab to the x, a is a non-zero multiplier and b is the base. The value of a is the y-intercept of the graph of the function. The value of b is the ratio of y values whenever the x value increases by 1. An exponential function is increasing, meaning a is greater than 0 and b is greater than 1, and decreasing if a is greater than 0 and b is between 0 and 1, meaning that b is a fraction. Regardless of all the b values, all the exponential functions where a is greater than 0. They have no x-intercepts. extend from quadrant 2 to quadrant 1, and have a domain of x is all element of all reals, and the range is y is greater than 0. So we've just covered all of that. So there's nothing new here for you. Okay, so let's graph this guy, and then let's see what it looks like. So y is equal to 8 2/3 x. Okay, so before I graph it on my calculator, is it going to be increasing or decreasing? Pardon me?
Decreasing.
Why is it decreasing?
Because of the,
Because what? The 2/3. The base is a fraction, right? So therefore, it's going to start up and come down here. All right, so now, if I ignore the 8 for a second, what is this coordinate right here? If I ignore 8 for a second, what is this coordinate?
that's 8.
For me?
It crosses at 8.
No, I'm ignoring the 8. What is it? Where does it cross? Where do they all cross at? 0 and 1, right? Now, what does the 8 do to the graph? It doesn't move it up. It makes it steeper, right? Because you're multiplying all your y values by 8. So now this coordinate is actually, like you said, 0 and 8. So I multiply all the y values by 8. That's what this does to the graph. So it makes it go a lot steeper than the original graph of 2/3 to the x. Okay? And again, put it on your calculator. All right. How many x-intercepts are there? None. What's the y-intercept?
0.
Okay. Domain? Good. Range?
Y is equal to 0.
No. Y is what? Greater than 0. Never equal to. Whether this function is increasing or decreasing?
Decreasing.
Decreasing. The end behavior?
2 to 1.
2 to 1. Done. Okay? And then it said verify it using technology. Well, we don't have to. All right? Any questions so far? Okay, this section's not very difficult.
For the range, would it be is y is greater than 0?